YouTube, welcome back to another episode of Intuition. Today I'm going to be teaching you guys how to solve GRE math problems. If you're new to this channel focuses on problem solving. The reason for that is that I believe that that's the best way for you to learn. The more problems you solve, the more practice you get, the better you become at math and science. So most of these episodes, I'm going to be demonstrating how I go about solving specific math problems or science problems in general so that you can ace your exams and become smarter. Okay? And let's solve these problems together, okay? All right. So, problem number one. Problem number one states, if n is an odd integer, which of the following must be an even integer? Okay, so with these kind of problems, you want to make sure that you understand the setup of every problem that you read, every problem that you go over. You want to make sure that you understand what the problem is asking for and what the setup is. Okay? Especially with a lot of these standardized tests, they like to put tricks in there. Okay? So this problem could be a little bit tricky, and what makes it tricky is the word if, right? It says if n is an odd integer. Well, that can confuse people because you might think, well, is it or is it not? Well, the word if it says the word if it is, then pretend that it is. So for all intended purposes, just pretend that, well, it is. So instead of reading this question as if n is an odd integer, I would just eliminate the if and just read the question as n is an odd integer. All right? So rereading the question, I would reread the question as n is an odd integer, so which of the following must be an even integer? Now that we've established that n is an odd integer, well, which odd integer is it? Well, they didn't specify, right? They didn't say exactly which odd integer it is. So that means that you can pick whichever one you want. Which one do you choose? Well, you choose the one that will make it most convenient for you to be able to answer this question. Okay? So what's the simplest odd integer that you can think of? Well, the simplest odd integer I can think of is the number 1. So that's the number that I would pick for n. So I'm going to say that n equals 1. And then what I would do is I would plug the value for n into each answer choice and see which ones gives me an even integer. Okay? So for a, that's n over 2, so that's 1 over 2. Is that an odd integer? Well, no. 1 over 2, that's a fraction. So remember, I can choose I can have n be whatever I want it to be, right? So here's the thing. So maybe I can try, so 1 over 2 gives me a fraction, and I'm looking for an integer. So maybe I'll try 3, right? That's the next odd integer after 1. Well, 3 over 2, that's still a fraction. Hey, then I realized something. Wait a minute. Any odd integer divided by 2 is going to give me a fraction because 2 does not go into an odd number evenly. So I know that a can't be the answer, right? An odd integer divided by an even integer is going to give you a fraction. So a can't be the answer. And then I move on to b. Well, for b, it says 4n plus 3. So that's 4 times 1 plus 3. Now what does that equal? Well, 4 times 1 is 4, plus 3, that's 7. Right? Because 7 is an odd integer. It doesn't give me an even integer, so b is not the answer either. Okay? So now I'll try c. C is 2 times n. That's 2 times 1, which gives me 2. So finally, I plugged in my value for n, and I got an even integer. So c looks good. Right? And I can basically stop there. But just to be thorough, we'll continue with d. And d is n to the 4, which will be 1 raised to the 4th power, which just equals 1. D is not the answer. Okay? And then e, we have e, which is the square root of n. So that would be the square root of 1, which just equals 1. That's also an odd number. That's not the answer. Our answer is C. Okay? Easy, right? All right. So let's move on to the second problem. Question number 2. Question number 2 states that if x and y are perfect squares, then which of the following is not necessarily a perfect square? So this problem is pretty straightforward, right? It's telling you that x and y are perfect squares. It says if, but remember, if you see if, it basically just pretend that it is. Just get rid of the if and just say x and y are perfect squares. So x and y are perfect squares, and it wants to know which of the following answer choices is not necessarily a perfect square. So all we need to know is, what is the definition of a perfect square? Well, a perfect square is just a number where when you take the square root of that number, you get an integer. So for example, 1 squared equals 1. The square root of 1 is 1. 1 is a perfect square. Let's try 2 squared. 2, which is 4. The square root of 4 is 2. So 4 is also a perfect square. And so on, right? 3 squared would be 9. The square root of 9 is 3. That's an integer. So 9 is also a perfect square. So since we know that x and y are perfect squares, and the question doesn't specify which perfect squares they are, we're going to assign them perfect square numbers, right? So, and don't let them be the same number, because you want to be able to differentiate which one is x and which one is y. So I'm going to give them different perfect square numbers. So I'm going to give x 4, right? And the square root of 4 is 2, right? So in this case, x is a perfect square because x is basically equal to 2 squared. And then I'm going to let y equals 3 squared, which is 9. All right. And then I'm going to plug these numbers into my answer choices to see which ones does not give me a perfect square. So let's look at A. A is x squared, right? So which is 4 squared. Well, remember, a perfect square, all you got to do is take the square root. If you take the square root and you get an integer, it's a perfect square. When you take the square root of 4 squared, what do you get? You just get 4, right? The square root of 4 squared is 4. So that's a perfect square, and it has to be a perfect square. So A is not my answer. Let's move on to B. B is x times y. That's 4 times 9. And what am I going to do? I'm going to take the square root. All right. Now, as I take the square root, what do I get? I get the square root of, what was 4? 4 was 2 squared. And 9 is 3 squared. Okay, so now what does this equal? Well, inside the square root, I have 2 squared and I have 3 squared. So I can combine the squares, right? So that would be equal to square root of 2 times 3 squared. 2 times 3 is 6. So this is basically 6 squared. And the square root of 6 squared is what? 6. So that's an integer. So this is also a perfect square. B is not my answer. So answer choice C, which is 4x. So that's 4 times 4. Which gives me 16. All right? Is the square root of 16 is 4 times 4. So the square root of 16 is 4. Now, but with this one, what I want to do is, this problem only involved an x. But what about y? I could have easily let y equals 4 and let x equals 9. So I'm going to try this out again for y. So let's say x was equal to 9. So I'm going to do 4 times 9. And I get the square root of 36, And is that a perfect squared? Yeah, 6, right? So 6 times 6 is 36. So this is also a perfect squared, and it's not my answer, right? So now we move on to D. D is x plus y, so that's 4 plus 9, which equals 13. So is that a perfect squared? If we take the square root of 13, that is not a perfect squared, right? There's no number, there's no integer I can think of that when you multiply by itself, you get 13. Then we can try. 2 times 2 is 4. That's 2 is not the answer. 3 times 3 is 9. 3 is not the answer. 4 times 4 is 16. And I'm already past 13, so no. This does not give me a perfect squared, and that's my answer. Okay? All right, so there you have it. Thank you guys for watching. If you have any GRE questions, SAT questions, or basically homework questions from your math or science class, go ahead and leave it in the comments below, and I'll be sure to answer your questions in upcoming videos, okay? Remember, as always, learning is for everybody, so keep watching. Thank you.